Hi, I'm Begum.A.
Myself Begum.A.
Myself J. Street. Our project guide is Dr. A. Begum, ME PhD, Assistant Professor, RMD Engineering College.
And our project title is Real-Time Detection of Driver Cognitive Distraction Using Machine Learning Classifiers.
According to the survey, 5 to 25% of the road accidents are due to the missing concentration of the drivers. The distraction of the drivers are of three types, including visual distraction, manual distraction, and cognitive distraction. Our approach deals with the cognitive distraction of the drivers. That includes closure of eyes, rate of blink, and yawning using machine learning classifiers. Thus, when the driver misses his concentration in driving, he will be alerted by an alarm. So, by using this, the road accidents that are caused due to the driver's distraction can be reduced.
Now, let us see about the workflow. There are two different phases in this workflow. The first phase is the training phase and the second phase is the testing phase. In this training phase, the video input is given through the web camera. This video input is then sampled into frames and these samples are called as training samples. These training samples are then pre-processed using a method called as clash. The clash is nothing but the contrast limited adaptive histogram equalization. These pre-processed samples are then used for feature extraction. The extracted features are the mouth and the eyes. These features are extracted using an algorithm called as Weiler-Jones algorithm. Then these features are stored in the database. Now for this training process, there are three different stages in this training process. The first stage is this extraction of features, the second one is grouping, and the third one is training. For extracting a feature and storing it, we need to first create a database. The code for creating a database is shown in the screen. Once this code is run, a database is created. This database consists of features such as right eye, left eye, and mouth. These features consist of both the closed and open states. These states are then grouped separately so that it will be used for the training. These closed and open features are trained such that closed ones represent the non-fatigue and the open ones represent the fatigue state. So once the CNN is trained, it will be easy when it's used in the testing phase. For training the database, the code is shown in the screen. When we run this code, the training process is completed successfully.
After the training of the database comes the testing phase. The first step of the testing phase is giving the driver's continuous video as input, which is taken using the webcam. And the video is now converted into grayscale frames. Following this, the pre-processing and feature extractions are done similar to that of the training phase. The samples in the database are classified using the ResNet50 convolution neural network. That is, ResNet50 is used for image classification and it has 50 layers so that the accuracy of the classification is high. The demo for the testing will be shown now. The output of the testing phase shows whether the driver is fatigued or in non-fatigue state. Fatigue means abnormal features such as the closure of eyes or yawning. And the code for the fatigue feature extraction is shown in the screen now. On the other hand, non-fatigue means the normal features and the code for this is shown now on the screen. Finally comes the main code. Here the driver's video is monitored continuously and when abnormalities are detected, the fatigue state of the driver is indicated by an alarm. When there is no distractions, he is assumed to be in a non-fatigue state. This is done by using the feature matrix that is being shown on the command window.
Hence, we conclude that by designing a real-time reduction of driver's cognitive distraction using machine learning classifiers, we can identify the driver's fatigue state and the driver will be alerted. The training phase makes the system robust and adaptive. Thus, this method will be efficient for people with different facial and eyelid features. The accuracy of this is also good and hence the number of road accidents will be reduced.